starting with the name of Allah, who is the creator of this whole universe. Assalamu alaikum and good afternoon to all of you. Ladies and gentlemen, I welcome you all to the fifth workshop of Solidworks Bootcamp. This is your host of the day, Miriam, an executive member, Team Documentation, 𝐈𝐌𝐞𝐝𝐢𝐚 Student Chapter. Without taking much of your time, permit us to start this session with the name of Allah Almighty.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم اقرأ باسم ربك الذي خلق خلق الإنسان من علق اقرأ وربك الأكرم الذي علم بالقلم علم الإنسان ما لم يعلم كلا إن الإنسان ليطغى أن رآه استغنى إن إلى ربك الرجعى.
Jazakallah. The Institution of Mechanical Engineers is an independent professional organization that represents mechanical engineers and the engineering professions worldwide. 𝐈𝐼𝐞𝐝 was founded in 1847 and is headquartered in London, United Kingdom. The institution has over 128,000 members in 140 countries. 𝐈𝐼𝐞𝐝𝐢𝐚 chapter is the first student chapter of 𝐈𝐼𝐞𝐝 UK in any public sector university of Pakistan. It is the leading technical society of the university, focusing on professional grooming and imparting true technical skills to the undergraduates. It has organized several local, regional, and a national event in the campus and has also won several distinctions both nationally and internationally. Our aim is to equip students with strong professional, technical, and academia skills. Solidworks Bootcamp is a training program designed to provide hands-on experience and practical knowledge of SolidWorks. It is a popular 3D modeling software used in various engineering and design applications. The objective of the SolidWorks Bootcamp is to provide participants with the necessary skills and expertise to create complex designs and assemblies, as well as to prepare them for the SolidWorks certification exam. The purpose of the SolidWorks Bootcamp is to provide participants with a comprehensive overview of SolidWorks software, its features and tools, and how to use them effectively in real-world applications. The bootcamp also aims to enhance the problem-solving and critical thinking skills of participants, as well as their ability to work in teams and communicate effectively. The previous enlightening session was all about additive manufacturing, and today's session is included in the module of SolidWorks animation. Let me introduce you all to a speaker of today's session, Mr. Yahya T. Kidhr. Yahya is an Egyptian electronic engineering student as well as a 3D designer and animator. He started his SolidWorks journey in 2016. In late 2020, he became a SolidWorks champion when he passed the Certified SolidWorks exam in Mechanical Design CSWEMD exam at the age of 19 and started a series of articles sharing his journey to the certs with the global community to guide and help others. 6 months later, he gave his first SolidWorks user group network SWAN presentation, and on the same day, he got featured in the SolidWorks blog for his animations that got hundreds of thousands of views and counting. Fast forward to today, he's an 8x SWAN presenter a 3D experience world presenter, and the very first mere user to come on a SolidWorks live design as a designer too. Before handing over the stage to our speaker, following are some instructions you need to follow. Participants can turn their cameras on as per convenience. Please have your laptops ready. You should be sitting in a quiet and proper place. The procedure for asking questions will be by raising your hand or by asking in the WhatsApp group. So for further insights, I'll be handing over the stage to Mr. Yahya. Over to you, sir.
Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. First of all, I'd like to thank you, Mariam, for this amazing introduction. And without further ado, let's get into today's session. So today in our fifth workshop of the Solidworks Bootcamp, we're going to be talking about Solidworks animations. So this is a bit about me, just to know more about who the presenter is, but I think Mariam already did an amazing job, so I'm just going to skip this slide for now. And let's get right into the topic of today. So first of all, we're going to talk about what are motion studies in general, what they are, how they're used, and what the types are. After that, we're going to get into each specific type in specific, and we're going to talk about animations. Then we're going to talk about basic motion, and we're going to talk about the differences between each of them and show you live examples of each. At the end of today's session, we're going to talk about exporting your animation, whether it's like a video file or even as images, to be able to spread the animation and share it with others. So first of all, motion studies. Motion studies in general are a way of conveying motion or showing motion of your already created 3D model. So one might ask, why use motion studies? So there are three main reasons I think of when I ask myself that question. First of all, they are eye-catching. So for example, if you look at this animation, you're going to see that having the model in SolidWorks is one thing, but finding this model and seeing it while it's moving is something else. So it conveys the motion and it starts catching the eye of whoever is seeing your animation. It starts attracting attention and therefore people will be more interested into seeing what you do. The second thing is that it can be able to show you models in motion. So for example, if I show you a still image like this, you might still wonder, what does this mechanism do? Because you still don't know from just a still image. But if I show you an animation of it, something like this, now you can see your model in motion and understand how it moves and how the parts interact with each other. The third and last thing I think of is to be able to show your model from different views or angles. So for example, we all know this infamous logo of Adobe Reader, but having it like 2D and still in front of you is one thing, and look at it from a different angle, something like this is totally different. So not just showing your model in motion, but you can also see your model from different views or angles, and therefore you can add one more dimension to your models. So now that we know why motion studies are important, now let's talk about their types. So in general, there are three main types of motion studies. There's animation, there's basic motion, and there's motion analysis. Unfortunately, motion analysis won't be covered in this session because motion analysis is only for users with SolidWorks Premium. As for SolidWorks Standard and Professional, they come with animation and basic motion. So this is a quick slide talking about the differences between animation and basic motion and what the differences are in the calculation weight of both of them. So in animation, it's based on one of two things, either key points or motors. So if it's based on key points, it's like going to one still frame of your animation and staying the state and then going to another place in the animation, let's say after 2 seconds, and creating another state, and telling the software to move from the first state to the second. As for motion, you add the motion using a motor and specify the motor's parameters, whether it's direction or the speed, and then let the software calculate it. So what you get from that is that while I'm creating the animation, I'm telling the software what the inputs are, and I already know what the output is going to be. On the other hand, basic motion is a little bit like simulation. So you specify some vague parameters like gravity, like contacts between certain parts of your model, and then let the software run the simulation, run the animation, and then create the motion for you. So you only specify the inputs, and the software will calculate what the outputs are going to be. So instead of just talking, let's show you. So let's start by animations. So as I said, we can control animations using key points or motors, and there's something else called animation wizard that I'm going to show you at the end. So let's start with key points. So the main or the easiest way is just by basic dragging. So you put the animation in one state, drag it with your mouse, and then save it in the next state. But that's like not calculatable, not mathematically correct. You can't like reference something in it. So the better way is using mates. Let me show you what I mean by that. So for example, this is an animation I showed before. And let me just show you what it looks like real quick, so you can expect what you're gonna see. So this is how the animation works. I've got a couple of bars that are moving right to left and so on. So instead of just picking them by hand and dragging them around, the easiest or better way is to specify mates. So if you look into my animation down here, you're gonna notice that I've got some mates, like this limit distance mate and this other limit distance mate, and I'm changing the value from one position to another. So for example, at the very start of the animation, this value over here, let me edit it real quick. It's this value, so 32 millimeters. And after 1 second, I change it to another value. So that value is, for example, 92 millimeters. And what the software does is that it changes the distance linearly from one part to the other. So as you can see, here it was a smaller value and here it increases. So let me just drag this. And as you can see, the motion is conveyed as I asked it to. The same thing happens over here and here. So if I just keep dragging this, as you can see, I'm controlling the model using mates. This is way better than just dragging your parts around, because at any time, for example, if I want to change this, so instead of 40, I can just change it to 30. And just like that, I know exactly where every part is going to be. And if I recalculate the model, as you can see, the animation will change according to the changes that I've made. The second thing is camera movements. So I can also use key points to animate camera movements instead of movements of the part itself or the model itself. So for example, I can end up with something like this. So this is an animation where the model stays still, nothing changes within the model, but what changes is the way I look at the model. So what I did, instead of using mates and changing the value of the mate, I added a camera and changed the parameters of the camera throughout the animation. It's the same thing. You add a key point at the start and a key point at the end and change the angle or the look of the camera through those two key points. Another thing you can do using key points is change the appearance of your model. So for example, if you want your model to become transparent after a certain minute or time, you can also do that in Solidworks. What you do, you simply just change the value of the appearance and save that as a key point. So as you can see in this short animation, I start changing the transparency of these red butts, and then I also change the transparency of the upper half of the model. All of this is done using key points. Let me show you real quick how I did this one. So based on the same thing, here are the key points, as you can see, multiple ones, and all I changed is the transparency for each value. So if you open any model of those, you can see the move, explode, and appearance. And this is the key point that we want to change. So as you can see over here, the transparency at the very start is 0%, and at the end, it says that the transparency is 75%. So if I drag the slider a bit, as you can see, that nail over there or that pin over there starts getting transparent. Let's try it with something a bit more obvious. So like over here, you're going to see that this half, the upper half, at here, this keyframe says that it's 0% transparency, and over here, it's 75% transparency. So when I drag this, it starts getting more and more transparent as time changes. The better thing that comes with using key points is that you can change their time just with your mouse, just like that. So instead of taking like a full second, I just change it to a half a second. So it's going to change very fast. Or I can even change the value. So all I have to do is just double click on it, and I'm going to change the value of the appearance. Or you can also do it from the left side over here. So from the appearance over here, you can also change the appearance like now. So for example, if I don't want it to be like 75% transparency, I can change it to something else. So I'm going to come to advanced, and from here, I can change the transparency. As you can see, the transparency amount from 0.75, maybe I want it to go 100% like that, and I'm going to click OK. And now look how it changes. So instead of going to 75%, it goes 100% transparent. All of this is done using these key points. Another cool thing with key points is that you can move them in group. So if I just do a box selection on them and start moving them, all of them will start moving together, just like that. And now if I run the animation, everything changes according to the new positions of the key points. Well, as key points are, they're not perfect because some motion can't be easily conveyed using key points, especially when the motion is either linear or rotary on a consecutive period of time. So for example, let's look at this. Here's an application where I want this to keep moving on and on and on. One might say, well, you can use limit angle mates and change it from 0 to 360 degrees, but that's only going to run once and it won't be able to loop it over and over again. But using motors, as in here, you can keep changing the value of speed or curse time. You can specify the direction of motion. You can change all of that very easily. All I had to do, for example, in this one, is just use this plane and mate the plane with this red link over here. So by adding a motor to this blue wheel over here and rotating that wheel, as you can see, all the chains move accordingly. Doing this using key points is possible, but it's going to be very, very hard. Using motors is way easier than that. And we're going to talk about motors a bit more in a second. So now that we know the differences and the uses of both key points and motors, what's the animation wizard? So animation wizard, from its name, it's a wizard. It just eases tons and tons of steps for you and just does them for you in a couple of clicks. So let's talk about that real quick. For example, let's talk about rotation. This is a slide I used in one of my previous presentations, specifically the 3D Experience World presentation, and it shows different ways of using rotation in your models. The one on the right and the one on the left are both rotation, but one of them is using the animation wizard and the other is used by like using key points and manual animation. Can you think which one is which? Unfortunately, even though the name animation wizard might be like a very cool name, but the one on the left is actually the one using the animation wizard. So even though it's very easy to make an animation using the animation wizard, it's not always perfect. So let's have a look at that. So here I've got the model, and all I've got to do is just come into here, and you're going to see that I've got already some key points that change the view of the model throughout the animation. I didn't create those by hand. What created them for me is the animation wizard. So let's just create a new motion study and go to the animation wizard button over here. From here, you can just select rotate model. Next. And now I just specify the direction. So for example, the x-axis, y-axis, z-axis. For now, let's do it around the y-axis. If I wanted to rotate multiple times, I can increase the number of rotations. But for now, let's just make it 1. And here I specify when I want it to start and for how long. So for example, I want it to start at the very beginning and I want it to last only 5 seconds. If I click finish, as you can see, it created these key points for me. And if I play, as you can see, it stopped rotating for me. So in just a couple of clicks, it was able to create this animation for me. But there's something to notice. So if I set this to start looping, I want you to pay close attention to the y-axis over here. So even though I asked it to rotate around the y-axis, even the y-axis itself is rotating. So in real life, if I really wanted to rotate around the y-axis, I can do that by rotating around the scene floor, for example, and start rotating. And if you pay close attention to the y-axis over here, when I rotate around the y-axis itself shouldn't rotate. It should stay still and the model should only rotate around it. But what we see in this case is not that. The only thing I can think of where this rotation of the animation wizard will be useful is if you're looking at the animation from this front. So for example, let's just look at it from here, like that. And let's change the view. And if I add the animation wizard from this position, let me just center it at the very center of the animation. Now let's add the animation wizard, rotate the y-axis, 5 seconds, for example. Now it's not going to do some weird things and it's just going to rotate as I expect. But as you can see, it's only from this plane. The moment I go to like a top view or like an isometric view, trimetric view, even dimetric view, it starts rotating in a very weird fashion. So this is the problem, but thankfully there's a solution, because as you can see, I created another one like this over here. Of course, it's going to take a bit more effort, and I'm going to show you right now how. So what I did is I created a plane a bit above the model like that, and I sketched a circle on that plane. So as you can see, I've got a circle over here. Then I used that circle to add a camera. So if I come over here, you're going to see that I've got a camera. And if I edit this camera, you're going to notice that I've linked the camera to that circle. So in the camera view, you've got two sides. This is the model view, as you can see, and this is the camera view, what you see if you use the camera. The camera uses 2 points, this yellow dot and this red dot. This red dot is where the camera is looking at. As you can see, when I move it around, the place where the camera is looking at changes, and the yellow one is where the camera is. So as I rotate it around, it starts moving to the left and right. So what I did is that I set the target. Let's say I want the target at the origin. Okay, maybe the origin is a bit too low, so I can also change it numerically using these values. Maybe something like this, so that the model is centered in the animation. And then in the camera position, I use this arc from my sketch. And as you can see, I've got this slider. So rotating this camera is based on moving the slider to the left and right. I guess you already know where this is going. So if I start at 0 and click OK, now I can start my new motion study. For example, let's make it also 5 seconds like that. And now I can get into this lights, cameras and scenes, and here is my camera. All I have to do is just get at the very end of the scene and create a new point like that. And now if I edit the camera, so I'm going to edit my camera from the properties. All I have to do now is just drag this to 100%, so it does one full rotation around the model. If I click play, as you can see, the y-axis over here is always still and the model is rotating around that y-axis. So now I've got model axis rotation instead of screen axis rotation as in the animation wizard. That's not all what you can do with the animation wizard. You can also create exploded views and use something called mate controllers. Let's start with exploded views. Many of you can create exploded views, but did you know that you can import them inside of your animation? You can get something like this. And not just that, I can also add a collapse animation after the explode animation to get something like that. So let's see how I did that. So if I open my model over here, you're gonna notice that I've already got my exploded view created. All I have to do now is just start a new motion study and go to the animation wizard. From here, I see the old rotate model option that we just saw a couple of minutes ago, but now I've got explode and collapse. So for example, if I choose explode and click next, I can also set the same duration and start time just as in other options. So for example, I want this to take 10 seconds and start at the very beginning and click finish. And as you can see, it automatically adds these for me. All these key points are created for me. And if I expand any one of these, as you notice, this is from the part itself. So all I have to do now is just play. And as you can see, the animation starts exploding for me. The cool thing about this is that I can come over here and use the animation wizard once again, but this time to add a collapse animation. But before I do that, one thing I like to do is just give the user a bit of like a couple of seconds to see the model as it is. So let's say half a second. And from here, I'm going to start adding the new animation wizard, collapse. I'm going to do the same thing. And as you can see, the start time now changes. For example, let's say 10.5. And the duration, let's make it 5 and hit finish. And as you can see, the software once again creates all the key points for me. Now if I click play, it starts the collapse once again in the duration I specified. Doing something like this manually would take ages, if not tons of time, but now I can just do the exploded view as usual and import that into the animation using the animation wizard. Now let's look at mate controllers. Most of you might not have heard about mate controllers because they are relatively new. They were added in 2016, but even that, they are huge time savers. So what mate controllers do is that they control mates, but not in a numeric fashion as like editing mate. What you now can do is edit multiple mates at the very same time. So doing so, you can end up with something like this. So as you can see in this animation, I've got a couple of mates that hold everything in place, and I can start adjusting the value of those mates. For example, here I'm using limit angle mate. So I change the angle every now and then, but doing this one by one manually is very, very hard. What the mate controller helps me do is do all of this in a very fast way. So let's take a look at this. So here's my model and everything is already in place and I've got my mates, and as you can see I've got these limit angle mates that specify every part of those and how it starts to move. And I also have my mate controller down here. But let's start from scratch and create a new mate controller from insert mate controller. As you can see here, I have the mates and the mate positions. All I have to do now is just tell it to find all the mates that it supports, and now it found all 16 of them. And now I can create and edit my positions from down here. So for example, here's the first position. Now let's add a new position from this button over here, the add position button. Let's give it a name. And now all I have to do is just start changing these sliders. And as you can see, I can quickly and easily change the value of all of my mates at once. Maybe something like that. Let's change some at the very end as well. If I'm like satisfied with this position, I can now click on update over here. And now this new position is saved. I can add one more position. For example, I want them to go back again. So like that. Maybe not all the way. And one neat thing is you can see this lock. If you click on that lock, you can now start moving the parts by hand or by dragging them instead of just using that value from the slider. And if I click on the lock once again, now I can still go back and change it from the slider. Once again, I'm going to update, and now I want everything to go back to the first position. So what I can do is I can go to the first position and I can use this button to duplicate my position. So if I click on add position, it's going to duplicate the current position, and then I can reorder my positions. So I've got 1, 2, 3, and 4. If I want to move something up or downwards, I can also do this from here. I'm currently satisfied, so this is position 1, this is position 2, this is position 3, and then everything goes back again. Now, what's left is to specify the duration. So how long should it take to go from one position to the next? I can do that from down here. So for example, I wanted to go from the first to the second position in 1 second, from the second to the third in half a second, and back again in 1 second. Maybe something like that. And if I calculate over here, as you can see, it starts calculating the positions that I've done and moving from one to the next very quickly. I can save the animation from here, or I can import this into my animation just as I did with the exploded and collapsed views. So I'm going to create a new motion study, and I'm going back again to the animation wizard. And as you can see, here is the mate controller option. So if I check that one, click next. Obviously, as you can see, I've got multiple mate controllers, so I'm going to choose the newest one. And I wanted to import it as key points. And as you can see, it tells that it's recommended for animation. If you're using motion analysis, then you're going to check the other option. But for now, I want it as key points. I'm also going to start the start time, but as you can see, the duration is grayed out. I can't change it. That's because the duration is specified inside the mate controller itself. Now I'm just going to click finish. And as you can see, if I expand this mates folder, all the changes are now created for me. All I have to do now is just click on play and watch. So as you can see, now I can have this animation created very, very quickly, just in a couple of minutes. The other thing I had to do instead of using mate controller is go and change them one by one and change the values as I go by. But using mate controllers, it just speeds everything up. One neat thing as well to remember is that these are all key points, which means that they are editable. So I can move this around, maybe box select those and drag them over here. I can change anything. I can even change the values. So if I double click on one of these, I can say, let's make it something like this and click OK. It's 100% editable. And now if I click on play, all the changes that I've specified will now also update. So as I said, this is way more accurate than just plain dragging. And since it's like just key points, you can drag them, you can change them, you can do any operations on them, just as you can do with regular key points that you've created yourself. One thing to note is that there are some mates that the mate controller can support and others that it don't. So these are the list of mates that it can support, whether it's the angle or limit angle mates, distance or limit distance mate, or even the width, slot, or path mates. Just remember that those last three can't be in the free position. They have to be changeable or editable using parameters, so whether it's the distance or even the percentage. Now that we've talked about animation and the different ways of motion, now let's talk about basic motion. As we said before, basic motion is a way of conveying physical or real-life motion. It's more like simulation. That's why we've got three main things that we can use in basic motion. We can add gravity, we can add contact, and we can use springs. In this session, we're going to talk about both gravity and contact. So gravity, it just simulates gravity as we know it in real life. It simulates the acceleration of any part that isn't fixed by itself. So if you've got a loose part and you just like leaving it in the air, if you play the animation and you set gravity, it's going to fall in the direction of the gravity you set. So for example, let's look at this. Here I've got some balls that are dropping, and as this wheel rotates around, they start falling from the other side, and they are dropping and moving like that due to the gravity that I've added in the animation. This is something that you simply can't do using animation. You have to do it using basic motion or motion analysis, because there's an element of simulation in this part. So if you take a look at the CAD file over here, you're going to notice that it's just like any other model, and in the motion study, one thing to change is over here. So the type of study, you've got to change it from animation to basic motion. Now I've got these three options. So I've got the spring, I've got the contact, and I've got the gravity. As you can see in my model, I've already got the motor that rotates this light gray disc. I've got gravity, which forces the balls to fall downwards, and I've got some contact, which we're going to talk about in a second. One thing to notice is that these have a number at the end of them. So for example, here I've got rotary motor number 2, and here I've got solid body contact number 2, but gravity, it doesn't have a number. Let's see why. So for example, if I start a new motion study and add gravity from over here, what I can do over here is I can specify the direction and the value of the acceleration of the gravity. So the direction can either be in the X, Y, or Z position. And to know which one you're choosing, you can look at this arrow over here at the very far right side. So for example, right now it's looking downwards. If I wanted to look upwards for any reason, I can just flip the direction over here and so on. I can also specify like an arbitrary direction. So if you wanted to go in this direction, for example, as you can see, it goes along my edge, and the arrow also shows that it goes really in that direction. So it doesn't have to be something realistic. As you can see, you can change it as you want. But for now, I'm just going to clear this and make it in the Y direction downwards. And as you can see over here, the default value is the gravity value of Earth. So now I'm going to click OK. And as you can see, I've got a note telling me that I'm still in the animation. So I've got to change that to basic motion. Otherwise, gravity is still going to be grayed out. So as soon as I change to basic motion, now it's activated and everything that's loose can now fall down. So let's just run this real quick. As you can see, nothing happens because I still haven't specified things to move around, because if you remember, I said that it only affects loose parts. Right now, every part in this animation is currently specified where its orientation or its position. But what I had in my previous animation over here, I had some balls. If I go at the very start of the animation, you're going to see that I've got some loose balls in the air over here. So if I run this one, you'll notice that those balls will start falling downwards, as you can see, because there are no mates that can specify where they are. So gravity affects them. So as you can see, we can only add one gravity simulation element in your animation. You can't add more than one. And something to remind is that motor-based animation is like a step above or a degree higher than gravity-based motion. So if you've got your motor moving something in one direction and gravity is going to pull it in the other direction, it's going to go in the direction of the motor itself. Now, let's talk about contacts. So we saw a glimpse of contacts in the last animation, but we didn't go in depth. So this is the animation that I want to show you, that's showing the collision between any moving parts and prevents them in general from intersecting each other. So in plane animations, if you've got two parts that are going to collide, they don't collide. They simply go through each other. Physically, that's impossible. No two parts or no two bodies can occupy the same volume, but when you're using simulations, you can specify certain contacts between your models. So let's see the preview for that. So as you can see over here, by rotating the handle at the bottom, the discs, the light blue discs start moving around and around, and these rods, which are standing on of those discs, start moving up and down. So this can actually be done in two ways. You can cheat the software and cheat it by adding like tangent mates or even cam mates and make it do that. But if you want to do it right, you can do it with simulation. And this is what we're going to do using basic motion right now. So here's our model, and as you can see, I've got my motion study. I've got actually two created. One is the cheat and the other is the real one using basic motion. So as you can see, this is just done using animation. And what I did is that I've got in my mates over here a couple of tangent mates. You can also do it using cam mates if you want, where these rods are tangent to these circles. And if I play, it gives me the effect that I want. But if I want to do it right, I can go to basic motion, as you can see over here. So I've got basic motion. Now I can suppress these tangent mates because I don't want them. Okay. You know what? How about creating it from scratch? We're gonna do a new one and suppress these. Now let's go to the top and start adding the components. So if we want to rotate this handle, we'll have to use a motor. Let me just zoom onto the rod over here. And as you can see over here, I can specify that I want it to rotate, not move linearly. And I can also specify the speed. So for example, if you wanted to go at constant speed or for a certain distance or to oscillate, go back and forth, you can change all of that. But for the sake of this animation, I'm just going to set the RPM something like 30. So it does one full rotation every 2 seconds and click OK. So as you can see, I now have my rotary motor, like as you can see down here, and I can also add gravity. So I need gravity to go downwards. The direction seems to be off, so I'm going to select the Y direction downwards and click OK. And as you can see, using this disclaimer, we still haven't changed it to basic motion, so that's something to keep an eye on. And last but not least, we've got to add the contacts. So as you can see from this contact icon over here, we've got multiple types of contacts, but if you look at it, you can only see one of them, which is solid bodies. That's because there's actually another type, but it's only for motion analysis. If you're using basic motion, you only see this solid bodies type. So now I can add my bodies that I want the software to calculate contact between. And remember this use contact groups option because we're going to get back to it in a moment. Anyways, all I have to do now is just select the components that I want to be that I want Solidworks to calculate the contact between. So for example, I want all the circles and all the rods. So I'm just going to scroll down here and select all of them. And as you can see, I've got over 500 contact pairs to be calculated. I'm going to hit OK. Remember, we only set the motor to rotate for 2 rotations, 2 seconds per rotation. So I'm just going to end the animation at 2 seconds. And now, if I click calculate, it's going to take some time because remember, it's calculating every possible contact between those parts. And as you can see, it's now done. If I click play, the animation is going smoothly. Let's play it once again. There it is. So that's one way of doing it. And as you can see, this compared to the animation that we did earlier, they both look similar, but one is like tricking the software and the other one is like doing real simulation inside of your animation. So In my slides, I have something called contact groups, and I say that they reduce the solving time. So that's the option that I said that we're gonna get back to, because, for example, here I just had a small number of components to have the contacts calculated between them. But let's say we've got like 100 components or even more than that, and you want to calculate the contacts between all of that. So sometimes not all bodies will collide with each other. So if we look at our part over here, these circles are already fixed in their position with respect to this rod. They can only rotate about each other. So, for example, one can't hit the other. The same goes for these rods. They will never hit each other, they will only go up and down because that's how the model is created. And that's how the geometry of the base that I stand in it looks like. So since I already know that these rods won't collide with each other and the circles won't collide with each other, I can tell the software to ignore the contacts between those. And this is the use of contact pairs. So if I just edit this whole body contact, let me edit it real quick and activate the use contact groups option. Now you're gonna see that I've got two boxes over here to fill up. So let me just clear this one. So what these two groups are is basically anything in the first group won't be calculated with each other, but it will be calculated with components in the second group. For that, I'm going to put all the rods in one group and all the circles in the other. So if I go real quick like this and select all the rods, they are in the first group, and the second group I'm going to select all the circles. So now I've reduced the number of calculations that the software has to do. Remember, there used to be 561, now they are down to 306. So we reduced it like a bit like the half. Now I can click OK and recalculate, and you're gonna notice that it calculates way faster than before. So as you can see, it just goes through it real quick and it's done. So just like that, if I click play, it's going to show me the exact same animation because what I removed was contacts between things that will never even collide with each other. So now that we've seen contacts, let's talk about exporting your animation. You've created it, whether it's using animation or basic motion. You've added some keyframes or key points. You've added some motors, maybe added some simulation in gravity. But the main thing is that once the animation or the basic motion is done on the software, you still want to show it to people. So now there are some tips and tricks to export your animations correctly. So remember that you can also change the model throughout the animation while exporting. And that's something you can only do in animation. You can't do it in basic motion or motion analysis. So for example, if I want to do something like this. Here I've got a pole and a ratchet, and I want them to change according to the rotation of one with respect to the other. So I'm not just changing how the model looks or where the model is or the view that I'm looking from. I'm actually changing the geometry of the model itself. This can only be done using animation because what it does is that it rebuilds the model in every single frame. So if I've got maybe like a video that's 60 or 30 frames per second, that means that I'm rebuilding the whole model 30 times throughout that animation. So to do something like this, let's look at how I did it. So here's the animation. It's all based on this model, and pay close attention to this icon over here. That arrow means that there are external relations, which means that this part has something in it that is dependent on something outside of the model. So if I open this part real quick, you're gonna notice that same arrow icon in the features at sketch 3 over here. What that means is that this sketch is actually based on something that's outside of this part file. Why is that? That's because I actually edited it inside of this animation. So what I did is that I go over here to the pool. and I start editing the part inside of the assembly. And now let's just drag all of this right back. And what I want to do is that I want this position of this ratchet to be corresponding to something in my part. So what I did for that is I used something called the intersection curve. That's not something that people use a lot, but it's really handy. So if I select the front plane and start a new sketch on it, remember, I'm creating a sketch inside of the pole part file, but I'm looking at it inside of the assembly. So what I'm going to do right now is I'm going to go to the intersection curve, and I'm going to select this outer shell of the ratchet. So the only issue here is that if this ratchet has multiple faces, that's going to be a very big issue because I'm going to end up with multiple parts. But what I really want is for this ratchet to all have one continuous face, as you can see right here, and I'm going to show you how I did that in a second. Now I'm just going to click OK, and as you can see, I should end up with a line that represents the intersection between this front plane, which is in blue, and the face that I specified. So it intersects that in this line and this line. I only want one of them for now, so let me just delete the other one. And here it is. And let me just exit the sketch. Let me just change the color so that it's easier to be looked at, maybe something like red. And now I can exit the component environment. And as you can see, sketch 4, which we've just created, also has that arrow on it over here, which means that this line is depending on this ratchet. So for example, if I rotate this ratchet a bit, that should move a bit back there, but it doesn't. That's because I still have to rebuild the assembly. So if I hit Control Q or Control B, as you can see, it starts moving. And if I rotate a bit more and hit rebuild, it moves even more, and so on. So every single moment while this moves, that line will also move accordingly. And what I can now do is that I can base my pole design based on that line that I've just created. And if that ratchet moves in the assembly, the pole will change the geometry of itself as well. So let me just open this part and show you real quick how it's made. We don't need this. And here's the sketch that I've used similarly. There it is. And now I've created this boss extrusion based on that line over here. So if that line starts moving around, that extrusion will also start moving around. Let's see in the assembly environment. Here it is. So if this starts moving like this and I hit rebuild, as you can see, this also moves with it. Let's rotate it a bit once again. And as you can see, it changes once again. So as I said, this is all based on the fact that this ratchet has one continuous face outside of it. How to do that? Let's open this part and see how. So this is actually a very simple part, just a couple of extrusions, as you can see. It was just used to show how this will be created. And if I open the second sketch, which is for that, and edit it, it may look like this should be like a line and an arc and another line and an arc patterned around, but in reality, this is all one continuous spline. How to do that? That's using a very cool and very neat feature called Fit Spline. You can search for it over here. Here it is. And what it does is that it simply creates one big spline surrounding all the sketch entities that you select for it. So for example, if I created a rectangle real quick, maybe something like that. If I select this rectangle and go to Fit Spline, what I'm going to do is create one spline that goes all around it. Let me just zoom in real quick. And from the tolerance value over here, I can specify how close it is to the corners of that model. So now let's click OK. And before I do that, remember that this is one line, this is another line, and so on. So these are 4 different lines. But as soon as I create the fit spline, as you can see, it's going to create this pink one, and changing that tolerance value to a very small value makes it closer and closer to the entities that I chose for it. If this is like a bigger value, it's going to have a wider tolerance, which is maybe not what I want in this case. So let's try something very small and click OK. Now what I ended up with is one continuous spline which mimics or surrounds the model that the sketch entities that I've chosen for it. As for the old rectangle, it's still there, but it's now turned into construction geometry, so I won't need it anymore. That's also the same thing that I did over here. So after creating the sketch itself, I selected all of them and used the fifth spline to ensure that it's all one big extrusion instead of multiple faces for my extrusion. So back again, if I just select one part, as you can see, all of it is selected. Now all I have to do is just go back to the animation and just simply add one motor to this part so it rotates around itself. And as you can see, using this linking or the external relations, I can now force this pole to rotate with the ratchet and also change the geometry accordingly. So one last thing, let me just unsuppress these two features that I've suppressed. They're simply just linear patterns of that arm. And now if I go to my motion study, as you notice, all I have is simply this rotary motor, nothing else, no contacts, no gravity, nothing. And as you can see, it's also an animation because that's the mode that ensures that this is going to rebuild every second. Now, if I set this to loop and play, as you can see, while this moves, the arms also move with it. And this is how the motion can be created. As I said, this is all based on the fact that animations rebuild the motion every single frame. So now that we've talked about exporting, we're not done yet because there are still some things to take into consideration. So most of us will export our animations as videos, but we can also export them as a series of images. So for example, if the video is 30 frames per second, that means that there are 30 images that make up that video. So instead of exporting the animation as a video file, you can export it as a series of images, whether they are PNG, JPEG, or even BMP, and get those frames for yourself. That might not sound useful for many of you, but if you want to create GIFs, like something that I love doing with animation, that's the very best way to do that, because you can now take those frames, import them into any free software like GIMP or Photoscape, and create your GIF for you. One other thing is that the way or the file format that you use will change the file size and the quality of the exported animation. So if you look at this real quick, the very widely spread file format that people used to use when exporting Solidworks animation is AVI. And for the longest time I can ever remember, I've always been asking people to stop using AVI and start using MP4. And now I've got proof that MP4 is way better than AVI. So as you look over here, AVI, it can be compressed or uncompressed, and you can even vary the value of compression you want. So if you want an uncompressed AVI, this animation, as you can see, it's only 4 seconds, but the uncompressed version of it is like 300 megabytes. That's over quarter a gigabyte. So let's see how this animation looks like real quick. So the animation looks good, it's crisp and nice, and the edges are very sharp, but that's only 4 seconds. Do you think it's worth like 300 megabytes of your storage? On the other hand, if you compress the AVI file to a high extent, you're gonna end up with like 1.5 megabytes. That's way smaller, but let's look at the quality real quick. So there's just stuttering, the image quality is just bad, the colors aren't clear, there are tons of issues with this. It's the exact same 4 seconds, and a smaller size, but the quality isn't just good. So one thing to keep into consideration is that you've got to adjust the value of compression accordingly. Too much will make the file very small but like unusable, and very small compression will make the file way big, but it's going to end up with a nice quality. But there's actually one more thing to check out, which is MP4. So this is the same animation, same 4 seconds, but it's only 23 kilobytes, not even megabytes, it's in kilobytes now. And look at the quality. So as you can see, it's got perfect colors, crisp edges, everything is looking smooth and nice, and it's only in 23 kilobytes. That's amazing. So if you've got 2018 or higher versions of SolidWorks, while exporting your animation, you're going to find the option to export as MP4, and while doing that, you're going to notice way better quality and file sizes differences. Apologize, it's actually 2020, not 2018. So MP4 was added in SolidWorks 2020. So it's in 2020, 2021, 2022, and so on. So if you look at the animation real quick, and we're going to see how to export it. So here's the motion study. And for exporting the animations, we're just going to go to the Save Animation button over here. If I click on it, I end up with multiple options. So the first thing I want to notice is the file type. So they've got AVI, FLV, MKV, MP4. All of these are video file formats. So any one of these is going to give you a video. But as you can see, you also have series of BMP files or PNGs or JPEGs and so on. So what that does, it just exports every single frame as its own image. So since we've been talking about frames, you can also set the number of frames per second, and like generally speaking, higher is better. So let's say 30 or maybe even 60 frames per second is way better than the default 7.5. Just choose anything, 24, even 29.98, but just don't use 7.5 because the animation will end up very choppy and it won't be like a smooth animation. So maybe something like 30%. So last thing is the image size or the aspect ratio, and that means how many pixels is the image wide and its height. So if you're using cameras like I'm doing in here, so you can simply use the camera's aspect ratio. So if I go like this, changing one of them will change the other. Or if you want to do like a regular aspect ratio, so for example over here I'm gonna go with something like that. Or I can choose one of these, and I prefer 16:9 because 16:9 is one of the standards, especially for social media posting. It ends up with a very high number of pixels, and you also end up with like a good looking image, whereas for mobile or even looking at the desktop. You can also use 1:1, which is good if you're using like your animation is mostly all the models and all the parts are in this very center. But if it's widely spread across the scene, you can start looking at something like 16:9 because it's better for wider view content. So if I like choose all the settings and everything is good to go, now I'm going to click on save. And now I'm got the option to specify the compression. So here I've got the compression engines. Here's full frames, which is uncompressed. And as I showed you, that gives you a very high quality, but it's also giving you an insanely high file size, which is not something that most of you would want. So based on the codecs that are installed on your device, you can choose one of these compressors, and the compression quality comes over here. So you're going to choose regularly like something in between. You don't want it to be very low or even very high, because either way you're either going to sacrifice the file size or you're going to sacrifice the quality. But if I export it as MP4, notice what I get now. So here's MP4. I'm going to set everything, so maybe full HD. So it's 1920 by 1080 and 30 frames per second. And if I click on save, let me just put that on the desktop real quick. It doesn't ask me for anything. It just goes straight ahead and exports the animation for me. Doesn't ask me about the compression or anything. It does all of that behind the scenes and ends up with a very high quality video with a very small file size, as you guys saw. So I'm going to leave it run in the background, but with that being said, let's just recap what we've said. So AVI, it needs very precise handling with the file compression, while MP4, it just balances everything. So it balances the file size and it also balances the file quality. So with that, we've reached the end of today's session. I'd like to thank you all for joining us today. And if you've got any questions, I would like to hear them.
Thank you so much, Mr. Yahya. Now we'll be having a Q&A session. If you have any questions, please ask in your WhatsApp groups. Okay, so sir, I have one question. That can you please tell that do animations disturb our mates in assembly?
So generally speaking, they don't change anything that you don't change yourself. So as you saw while I was changing, for example, the values of the keyframes, that's only inside of the animation. The moment I exit the animation or the motion study, the values return once again to their original values. So let me show you that real quick. So if you open the model that we used at the very first, so here it is. As you can see, everything is at a certain value. If I go to the motion study and change those values, so maybe as you can see over here, the values have changed. But if I go back to the model, everything goes back to normal once again. So any change that you do in the values is only going to be saved inside of the motion study. But as soon as you go back into the model, all of those are eliminated.
Yeah. Okay, so I have a question number 2. Can you create exploded views and animations in SolidWorks? And if so, then how can we do that?
Well, of course you can, and that's something that I just went way ahead of in today's session. So I didn't show how to create them, I only showed how to use them, but you can certainly create them. It's from Configuration Manager over here. So if you go to the Configuration Manager, from here you can simply right-click on any configuration you have. So I already have my default configuration. If I right-click, I can start a new exploded view, as you can see over here. Or if I already have an exploded view, I can simply right click and edit it as I want. So changing exploded views is simply changing where each component is, disregarding all the mates that you've added. So keep that in mind. So let me just add a real quick exploded view real quick. So first thing, let me, for example, choose this component, and I'm going to drag it maybe in this direction for a certain value. Maybe then I want to move this component with it. So that's one step. And I click done. So that's the first step. Even though there are mates that confine these to their original positions, doing an exploded view simply disregards all of these mates and starts moving the components in the way you want. So for example, if I want to add another step, maybe I want to move this one in the Y direction, maybe like that, and go ahead and click on done. So that's the other step, as you can see. So I've got the first step and the second step. Maybe I want to rotate a certain component a couple of times. So let's say I want this one to move in the X direction, and click done. And then in the second step, I can rotate it using these, as you can see. And I can call that the second step. And if I hit OK, now I've got two exploded views. And I can simply just go into my animation, use the animation wizard as I've shown you to import that exploded view into my animation. So just like that, if I click on play, that part is going to move out and then rotate just as I specified inside of the exploded view.
Okay. Thank you very much. I have another question that we know that SolidWorks is excellent in showing the working mechanism, but the output is neither good for product nor very attractive. So how can the results look more realistic in terms of appearance and textures, like other softwares, for example, Keyshot and Blender show attractive output results of animations?
That's actually a very nice question, and that's going to get us into something else in the models. So if you notice, let's say I create a very quick model real quick. So the default appearance for most of the models is like a light gray appearance. I'm just going to do something very simple over here. So maybe I'm going to extrude a cylinder, something like that. I'm not even going to specify any dimensions. I'm just going to show you something real quick. So if I do something like this, you're going to notice that it's light gray. So any components that you create will all have that color. So the first thing is go to the appearances tab and start adding some colors and appearances to your model instead of this default color. So if you noticed, all of the animations that I've showed throughout this session, they all have colors in them. I always try to show every component in its own color. So if I've got two components very next to each other, I give each of them a different color so that the viewer can say which one is which. That's the first thing. The second thing is you can actually turn on real view graphics, which gives you a bump in the graphical performance of your parts or even the animations as well. So for example, you can see the difference when I add shadows or even add perspective. All of these just add more realistic things to your animation. I can even add ambient occlusion, which like adds some shadows at the very dark edges in a more clear way, and so on. So if I check this in a animation that I've had, maybe something like this one. So as you can see, now it looks way more realistic than turning off real view graphics with this just blank everything and so on. So that's one thing to do, which is just try and add real view graphics. Now you can specify a specific appearances, some scenes to go in the background, and so on. That's one thing that you can do inside of SolidWorks. Other than that, you have to use other software, which is SolidWorks Visualize, for example, which is only for rendering. So it's like a standalone software, which is mainly for rendering your animations or your models. You can also use an add-in, which comes with SolidWorks, which is called PhotoView 360. It only comes with SolidWorks Premium, so I don't have it right now because I'm using SolidWorks Standard. But you can also use PhotoView 360, which gives you also a rendering performance, something like Keyshot, but obviously less power hungry and less results. So this is what you can get in your animations. So remember, if I just go into my motion study and start saving my animation, it's going to be saved in this state with the appearances, with the shadows, with the dark parts, with the light parts, with everything. But that's where SolidWorks can only do. Anything higher than that, you have to use a dedicated rendering software. As I said, you can use PhotoView 360, which is a built-in add-in for SolidWorks, or SolidWorks Visualize, or maybe you want to use something like Simscape or Keyshot or any other software.
Yeah. Okay, thank you so much. The next question is that if we put mates only in SolidWorks, so can we do these kind of animations in Keyshot also?
So I didn't actually use Keyshot myself, so I'm not sure how animation works in Keyshot, but I expect it to have a similar way of recreating motion, because I've seen animations that were created in Keyshot have motion like what we see inside of SolidWorks, but I'm not sure if there's a way to convert or transfer the mates from SolidWorks to Keyshot, because as you can see, I only use SolidWorks for my animations. I don't render them.
Oh, okay, okay. Okay, thank you. The next question is that what do the red lines in the animation tabs signify, and how do these red lines error can be resolved?
Okay, so the red parts are usually meaning that there's something that is erroneous or there's some sort of error in your animation. So for example, if you've got mates that are contradicting, that will give you an error in your software. So the same thing happens inside of the animation. You can set certain values of mates, for example, that aren't possible for the software to calculate. So in that case, if you change the value to something that is going to give you an error in the modeling phase, it's also going to give you an error in the motion study phase. But what you see is that the key point will change its color from whether it's blue or yellow or whatever color it is to red to show you that there's an error over there. And if you go with your mouse over that key point or keyframe, you should see a message that gives you more indication into what kind of error you're facing.
Okay, thank you. So the next question is that can we make a transition animation of appearance in SolidWorks, like transition of polished steel to cast iron?
So what you're asking is changing the appearance itself. Unfortunately, what you can do is change the colors of a certain appearance, but you can't change it from one to another. You can trick the software into doing that, by the way. So let me show you real quick something in the software.
Okay.
So for example, if we take this, for example, here I'm using a plastic appearance for this because this was meant to be 3D printed. So if I go to the appearances tab, you're going to notice that I've used polished ABS, for example. So here, instead of changing the transparency, let me create a new motion study where I change the color itself. So maybe I go over here and go with this half and drag an appearance one over here and edit the appearance. So if I change the material, this is the material inside of SolidWorks, which is used for like calculating the mass and so on. So for example, it used to be ABS, but I might say something like copper, for example. As you can see, the appearance still doesn't change because this material doesn't actually like apply over here. If I change the appearance itself, this is what I see in the software. So for example, it used to be blue. What I can do is that I can change the color over here to something else, maybe like red, for example, and hit OK. And the software is going to change the color from blue to red. But what he's asking is just changing it completely from this color that I've had to a very different material from the right side over here. So, for example, instead of plastic, now I want it to be like brushed bronze, for example. So here's brushed bronze. If I click OK, so here it is plastic, and then it transfers into the polished bronze appearance that you want. But remember, the material is still going to be the same. So that's just only an appearance that you see, but the material itself of the model is still going to be copper. Okay, because that's what I specified for the material.
Okay, thank you so much. So the next question is that how can one use motion analysis tools in SolidWorks to analyze the behavior of complex mechanical systems, like those found in robotics or aerospace engineering? And what are some best practices for setting up and interpreting these simulations?
So motion analysis is, you can think of it like basic motion but on steroids. So it's doing way better than basic motion in terms of simulating power and simulating capabilities. So what you can do is that you can extract plots from your animation. So for example, if you've got a robotic arm, for example, and you want to see the forces that that arm can handle, so you can extract plots for the force, for the velocity, acceleration, all those kind of things from your motion analysis, and use those values or those results to improve the design itself if it needs improvement. You can also use motion analysis tools to show simulation, so like real simulation for, like, let's say static simulation on a certain part while another force is exerted on it during the animation. So for example, if you've got a gripper and you've got the gripper holding something and you want to see if that gripper parts will withstand the force that are exerted on them, you can also do that using motion analysis. As you can see, we're talking about real simulation tools, not just mimicking physical things like what basic motion does. So that's where the motion analysis tool comes in handy, whether you want to perform reinforcement to your models, or you want to extract data or value from the model while it's in motion.
Okay, thank you so much. I guess they don't have any other question now. So thank you so much for answering our questions. Well, ladies and gentlemen, this wraps up our today's session. I would like to extend my sincerest gratitude to the speaker and audience for being here with us this afternoon and spending precious time with us. The next module will be covered by Mr. Deepak Gupta from India on 26th Feb 2023. Till then, have a blissful day, take care, and Allah Hafiz.